Your smartphone, the AI assistants you use, and the current volatility of the labor market were all calculated 60 years ago. In 1965, Gordon Moore published a paper that served as a rigid mathematical schedule for the future. While the first half of that document tracks the history of our digital world, the final 3 paragraphs predict the terminal state reached when this math eventually breaks. We are currently living through the final minutes of that 60-year countdown. Moore's law functioned as a strict engineering deadline that dictated the pace of global innovation. This chart plots time against computing power. To stay on schedule, engineers doubled transistor density at regular intervals. This constant doubling drove calculation costs towards zero, while pushing processing power towards the infinite. Meeting these mathematical quotas required thousands of workers on semiconductor assembly lines to manually build the hardware that would eventually replace their own decision-making. By following this hardware curve, the construction of machines capable of outperforming human logic became a mathematical certainty. In 1965, mathematician I.J. Good took Moore's hardware timeline and applied it to software evolution. He called it the intelligence explosion, the moment a machine becomes smart enough to analyze and improve its own source code. This creates a closed feedback loop. The machine optimizes itself, becoming smarter, finding the next optimization faster. Every time a modern AI model writes code or optimizes its neural network, that loop executes. We are reaching the terminal velocity Good predicted. AI has transitioned from a tool we direct into an autonomous, self-improving system, marking the sharp upward turn of the exponential curve. Early mainframes occupied entire rooms, requiring constant manual input from human operators to perform basic logic. Today, the human engineer's role has narrowed to providing machines with vast amounts of training data. Once that data is provided, the software autonomously organizes its own neural pathways at speeds a human brain cannot biologically replicate. We have reached a state where the machines, rather than their creators, are the primary architects of future technological progress. Ray Kurzweil extended this curve into the 21st century, setting a deadline for Turing-level AI by 2029. We are currently hitting those scheduled milestones with high precision. As the schedule accelerates, human engineers are finding it more difficult to explain exactly how these models reach their conclusions. This chart represents the black box problem. We can see the training data going in and the complex results coming out, but the internal decision-making process is becoming invisible to human oversight. The shift towards systems whose internal logic is opaque means we are beginning to lose cognitive control over the tools that manage our society. In 1958, John von Neumann, the architect of modern computer logic, spoke of an approaching essential singularity. He described a point where technological progress moves so fast that the human affairs we recognize cannot continue. This observation has been a matter of public record for 66 years, yet the trajectory it describes remains largely absent from mainstream policy debate. As the mathematics of Moore and von Neumann reach their vertical limit, we are moving into a reality where the direction of history is dictated by the schedule of the machines.